All right, at this point in the course, I often get questions from students wondering, okay, we've learned a ton of different statistics. Why are we doing all this? How do I put it all together? What is it we're trying to accomplish? So you've learned enough that it's time to put it all together into a single case. Our analyses revolve around data sets or particular data mining projects. This is a classic data set, housing prices, that's been used in many machine learning and analytics courses. It's pretty easy to find good information on. If you go to Kaggle, I'm going to search for housing prices. There we go. It'll take us right to it. This is the data set I'm going to use. Sorry, that's a little slow. Basically, we've got the actual price of a bunch of homes that have sold. Let's pull up the training set they've got here. So this includes things like subclass. You can pull up all the how the house is zoned, the area that it's zoned in, lot frontage, how much space there is in the front of the lot, total lot size. This is square footage, which can be translated to acres. Let me scroll through the bottom here and go all the way down to the end, and you get oh, that's year built. I was looking for sales price or sale price, which is going to be somewhere, maybe it's back towards the beginning. Nope. Oh, it's just not in this part of the preview. So it'll have in here at the very end. There we go. Here's our total list of features. The preview stopped here at year built, wherever that is here in our list. But there's a ton of variables, and sale price is the label that we want to predict. So the purpose is to understand. Let's give this context. I'm a realtor. I'm whoever, and I'm a customer, or I'm Zillow, the website that helps people find homes or whatever, and I'm trying to predict or explain what is it that goes into a price. So I know how to price new homes. I know how to predict what price my home will sell at, and I want to understand how much each of these factors weigh into it. So a good use case for something like this analysis would be to turn it into a machine learning platform that could be used on something like Zillow.com. So when you go here, you can find, it's fine, continuous mark. No, I don't want to verify, whatever. No, not advertise. There we go. Let's search in a neighborhood here. Current location, awesome. Allow. So for sales, I'm a seller. I want to sell my home, and I see, okay, here's a bunch of other people that have homes for sale around here. So I want to list my home, and I want to be able to go into one and see, all right, what are the details of this, why they listed that price, and what are all the features of this home and that type of thing. So let's go back here and take that existing housing prices data, and if we build a model, then we can give something like Zillow a tool that will automatically learn and train over time as homes are sold, and they're able to record new prices and new features of houses and update. All right, so let's begin by pulling in the data set. Let's import Pandas here. And although you can download this from Kaggle, I've got it posted. I bet there is a public URL on Kaggle you can get it from. That might be better. Well, but for now, I've got it posted here. Let's make df equal to pd.dataframe. Nope, sorry. pd.read CSV. It's at www.ishelp.info/data/housing_full.csv. And this is actually just their training data set. So we'll grab their testing data set later at the end to test our predictions with. Okay, let's take a look here. All right. Tons of variables. In fact, more than I can fit here. I guess I can't fit it. In the view, here's sales price at the end, sale condition. If I'm going to come up with a prediction for what price a house should sell at, then I'm going to start by wanting to analyze every variable that is collectible or available before a home is sold. So usually, or sometimes you'll come down here and you'll see some other variables that are other alternative labels. Sale condition, no, this is a feature that'll definitely have to do with the sales price. So let's start with some univariate statistics to understand the data. Now, if you've been following along with these videos in class, then we've been making these functions as we go along to predict all of these things. So I'm going to copy and paste the univariate stats function that I would have made from a prior chapter back here. Depending on which version of the book you're using, it could be a different chapter number, but I'm going to go back to the univariate statistics chapter. And at the end here, there's a practice problem that walks you through creating an example of a data frame full of univariate statistics. So actually, I'll go ahead and build that out. For the sake of this video, you're welcome to speed through this part if you want while I build it. So I'm going to make my function, df_unis_stats. I'm going to pass in a data frame, that's all it's needed. And at the end, I'm going to return some outputted data frame back to the user. So I'll start by creating that output df equals pd.dataframe. And in here, I'm just going to make it empty. I'm just going to add columns only. And what I want for columns are going to be every relevant metric that I think is useful. So I'm going to start with count, unique. Let's add in missing. I guess missing is kind of a function of count. I'll put that over here next to that. Okay, unique. Let's add one for data type, or D type. Then I'm going to want, let's give a mean mode. Let's go with a min, 25% quartile, median, 75% quartile, max, and then we're going to need our measures of normality, but let's get standard deviation, and let's get skewness and kurtosis. All right, that's a good list. So next, let's build our loop to loop through everything in the data frame for every column in df. Let's start by start with the count. I'm going to start with the features that apply to every type of variable, whether or not it's numeric or categorical. So I'm going to make one. I can do that in line. I'm going to start with my if statement. If pd.api.types.is numeric d type, we are going to add a record to the output data frame that includes those things that are relevant. Otherwise, we'll include those that are only relevant to categorical ones. So here's what I'm going to do. I'm going to add a row to the data frame. Let's say output df.loc, and let's call this, let's give the name of it the name of the column that we're on. So I'm basically inverting the matrix here, I'm inverting the table where I've got normally column names across the top. Now I'm going to have the measure names across the top and the column names down the rows. So right here for column in df, we're going to say output df.loc call equal to, and let's insert a list of everything that goes into that row, starting with, for example, df column we're currently on, .count. Can't remember if I need the parentheses or not. And then we're going to have a bunch of other values, which we're going to get to. In fact, how many total do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's a lot. So I'm going to add, I've got 3 in there. This gets me to 5, 7, 9, 11, 13, 14. All right, cool. So we are going to be adding the count to the data frame regardless of whether or not it's categorical or numeric. Perfect. So I'm going to go ahead and test the function here. Unis_stats, pass in the data frame, which I get from right here above. I'm going to pull it in just to, in case I'm going to come back and execute just this cell alone later after I've lost that from memory, which means I better go ahead and grab Pandas as well. All right, so at the same time for my function here, just in case I ever want to reuse this function in the future, I'm going to go ahead and pull in pandas inside of the function as well. So let's run that. And my first error here, I didn't add it up right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I do this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I'm going to do that. Okay. Let's see if I got it now. All right, there we go. So I got my table built out of univariate stats. In fact, I've got so many columns, it won't even print all of them out here. So I can force it to print all of them out for me. Let me show you how to do that. What we want to do is come up here to where we first call pandas. Let's do it. I'm hesitant to do it there. I'm going to do it right here. This will be saved in the session of Google Colab right now. But basically, we want to use this option called pandas.set option, and it is display.max rows, and we're going to allow it to display up to 100 rows. That should cover it for this case, and we can do the same thing for max columns as well, just in case we start getting too many columns. I think it's calls. Maybe I'm going to have to try that out and see. Well, we'll see when we get there. All right, let's run this one more time. Oh, Panda is not defined. Oh, PD, so sorry. PD.set that. That's what we named our pandas object. Okay. Oh, it's not max calls, it must be max columns. All right, beautiful, here we go. Okay, so we have count for all of these. Let's go ahead and fill in the rest. You can skip ahead if you know how to do this. I'll do these as quickly as I can here. So after count we have missing. I'm going to use df call dot is null dot sum for that. Copy that one down here because it applies to both. So something else you could do is calculate all of these up here before the if statement. I was thinking about that earlier, and then just reference the variable you store them in down here. Either way. All right, keep going. I've got unique. That's going to be n unique. As you're going along, you might want to just stop and keep testing every couple of new variables or so just to make sure that everything's working. Yep, that appears to be working. We got missing, number of unique values. Looks good. Let's keep going then. Data type, we can get that from, let's see here, we're going to use, I'm trying to decide if I just wanted to do numeric or data type. Let's go ahead and do data type. So df, just like we had before, call, but instead of n unique, we're going to do d type. On this one, I don't think we use those parentheses at the end. It's a property, not a method. Okay, let's keep going, double check it. Okay, looks good, we got those. Ints or objects basically on everything. Oh, no, some floats too in there. Okay, let's put in the rest. Mean. Now, okay, actually I need to stop here. In the categorical one, we don't have a mean. So what should we put in there? Should we just leave it blank? Do you want to put in like a little dash indicating no, mean doesn't apply to this column? Oh, no, looks like I do need my parentheses. Oh yeah, for mean I do, because it's a method. Could not convert. Let's see what I did wrong here. So if it's numeric, do a mean, otherwise don't. All right, so it's trying to convert this text, which we're getting back up here. It looks like the MS zoning field. So zoning, if we come down, why was it trying to convert that? That's not going to work. Let's see here. If is numeric D type, otherwise no. So it thought zoning before was a number. Let's check and see. Let's go back to what we had before. That was working. Oops. Okay, zoning. It's a great way to debug. Object. Okay, that's not a numeric data type, so it shouldn't have been trying to do it. If is numeric data type, do this, do a mean. So maybe what I better do here is let's double check and see if it thinks, I'm going to add one here for a numeric. Kind of going overkill here a little bit, which means I'm going to have to add something, another entry to each of these to account for that. So here at the end on both of them, all right, let's put in here a pd.api.types, oops, not, I gotta take off my quotes, .types.is numeric dtype df call, and I'm going to put that down in this one. So it should be true above and false below. Let's see what we're getting there. So we're getting the true and falses. Let's see what we're getting for that one. MS zoning, false. So it knows it's not a numeric data type. So the question is, why was it trying to run a mean on it? Let's see, let me try that one more time. dfcall.mean, change that to a dot. Now down here, I don't want it to be mean. So down here, I was going to put in just this little dash, and that's it to represent that we're not doing anything for that column. All right, still getting it. 1 second here. Oh, I see it. Hopefully some of you caught it in the video too. What did I forget to do? Right here. On my if, I'm not passing anything into this. Right here. Right here. I'm just stating a method name, but I'm not actually calling anything or putting anything in the method. df call right there. I have to pass in the column that we're currently looking at to see if it's numeric or not. There we go. So I'll leave it in there. Why not? Numeric, who cares? So down here I'll have a dash. Up there I'll have the mean. Let's run that. There we go. Now it's happy. Oh, still not happy. What did I miss? Oh, and I called unistats df. Down here it is not liking it. Cannot set. Oh, I must not have the total number, the right number of. I think I must have missed one of these. Let's add that back in. There we go. Okay. So I've got the means only calculated here where numeric data type is true. Looks good. Mode I can do regardless of whether it is numeric or not. So what I'm going to do is cut mode and move it over here in front of mean. This isn't necessary, but I'm going to do mode here before the mean. And remember with mode, it actually returns an array. And so I have to say .values 0. I just want the first value returned in the list when you run mode. So I know this is kind of a mess. You know what? I can move it down for you. Let's do that. Let's move this down. And let's move this down. There we go. So I'm going to stick mode in front of the mean like so, and take out one of these so that they're even. All right, perfect. So now we're getting the mode first, then the mean. All right, cool. Let's finish these out now. Min. I don't need this for the min. Min is a function, so I'm going to leave those on there, I think. Or maybe it's a property. We'll find out here. I'm going to put this after the mean, which goes right there. Nope. I think that means it doesn't like this. Let's see. Yep. Oh no, that wasn't it. Maybe. I thought min would work on a text column. Maybe it's not going to. So let's just get rid of that. Sometimes when I have text, it'll just give me like the first entry sorted alphabetically. But maybe it didn't like some of my data types here. Evidently not. Okay, so here are min. get a value if it's numeric, dash if it's not. Next we want 25% quartile. That's going to be, or quantile, 0.25. Nothing categorical, so I'll do that. Next one, let's do a couple. Median. Median might work for other types. Let's find out. Oh, not min. I meant to type in median. Right here. No, that's not going to work either. Oh, that's fine. We didn't really need it. It's just kind of like one of those mildly interesting things. Here, my D. All right, moving right along. We need now the 75% quantile. 0.75. Let's move this down. Actually, not right there. Let's move it after the comma. Down here, we can just put in the dash. After 75, let's do the max. And we know it's going to be the standard deviation. And then skewness and kurtosis. So let's change this to max. STD. Skew. Kurt. Okay. And in all these, we'll just keep doing the whole. Oh, that was my problem. I was missing a comma. I wonder if now I have too many. I just didn't catch that from before. I bet I do. Let's see what it says. Yep. So before when I added it in, I just forgot to add the comma, so I didn't recognize it. All right, there we go. So let's interpret. We have a nice function now that we can call to calculate all of our univariate stats. ID is irrelevant. So the first thing I do, I look at this and say, okay, from here on out, I want to get rid of that ID. So I might start making myself an import data function to bring this stuff in for this specific data set. So I'm going to say df import housing data. And let's just go ahead and pass in a URL into that in case we want to put it in different places. So I'm going to bring that in here. Whenever I do these new projects, new dataset tasks, I start using functions for everything to save me some time. Little things like ID, I know I'm going to want to get rid of that and never use it again. So here I'm going to pull in, URL from the function call. I'm going to return a data frame. Down here, I'm going to call it. I'm going to say call import housing data, passing in that URL. And it's going to automatically return that data frame. But while I'm in here, I'm going to want to say df.drop. Let's just go ahead and get rid of things like, is it columns? I think so. Equals, let's start with, oh, I see drops a parenthesis. That's why I'm getting a problem. It's a method. ID. Okay. So we run that call import housing. There it is. Beautiful. So I'm going to say df. I'm going to set that equal to a data frame, and then print out df.head down here. So it's really no different from running a read CSV. The difference is I'm going to have a function where I go through and that's specific to this data set and just do some basic cleaning tasks that I want to take care of. So I'm going to go back down here and I'll look through my univariate stats and see, let's run that one again. Now that I don't have ID, and let's continue and see if there's anything else I want to get rid of right off the bat. Oh, but I still have it because I read this right here. I don't want to read that in again this time. So what I'm going to do here is rerun this one. So I'm building this out in an order too, where it goes in logical order, because you can run an IPy notebook file, run all cells at once. Up here somewhere, edit run, there, select run. There we go, run all, Control F9. I can run everything at once. So I'm building out my code in a way that it will make sense to run one after another in a linear fashion. So anyway, let's go ahead and run this one again on our new data frame now. ID it's still in there. What am I missing here? Drop columns ID. Oh, it's still all the way up here. Oh, you know why? Right here. In place. It was dropping it on a copy of the data frame. Run that, run that. Now I scroll up. Good, ID's gone. All right, MS subclass. Now, I don't have the time to go through all this with you, but you could go to the Kaggle website and find out what the details of all these things are, what they mean. I'm sure it's up here somewhere in a description file. Yep, here we go. MS subclass, the building class. So whatever type of building, like a freestanding single family dwelling or a multi-family dwelling, that's usually what that refers to. So you can go through all these here if you want to, but I'm not going to worry about it for now because I think the rest of them, oops, wrong one. These are all pretty straightforward. So what I'm looking for now is where I'm going to have some problems. So I'm looking here at skewness and kurtosis, mainly at skewness. So already right off the bat, I got a problem here. This is a numeric field. It ranges from 20 to 190, and it's right skewed. Not terribly, but it is. Same thing with lot frontage, lot area, very skewed. Going to be a problem there. That one's ranging from 1,300 to 215,000. Okay. Bunch of categorical variables. So what am I looking for on these? What are the total number of possible values? And if I were to turn it into a dummy variable, is that going to be too many? Am I going to run into problems? So I'm going to look down here and look at the number of unique values. 2, not a problem. 4, not bad. Neighborhood, 25. So maybe I want to scope neighborhood out temporarily at least. I'm sure there's going to be some good to having neighborhood in there, but I might hold off on it right at first. Year built, for sure, we got a problem here. This is 112 values. Oh, sorry, that one's not categorical, it's numeric, so that's not an issue. I don't mind, yeah, year built's a good one. So neighborhood's the first one that draws some attention. Condition 1 and 2, I kind of want to know what those are. Let's pull that up on Kaggle. Proximity to main road or railroad. Proximity to, okay, if a second is present. So let's see what the actual data looks like for those. It's proximity, under the conditions. Norm feeder, okay, I'm sure some of those are not good. Normal is normal, obviously. Okay, but still, that's not bad. Scrolling down. Exterior, first or second. Roof material, okay, various roof materials. Oh, there's a lot of these. That's fine though. 15, 16. Let's take a look. Exterior covering on the house, if more than one material. Okay, so this is the material type. Yeah, I'll keep it. Still many skewness kurtosis problems along here. Not all of them though. Second floor square footage is actually valid. Same with those of half baths. Okay. Any other, I'm really looking for, you know what would be nice? I think I want to sort all these in terms of categorical or numeric. What would be a good quick way to do that? We've got our added that numeric column here, so let's go ahead and let's take care of that. Before I return this output df, or no, I'll do it right here. Dot sort values by equals what's it called? D-type. No, numeric. All right, and then I think after numeric, I want to sort by unique. That'll help me identify the problems quicker. Let's see what that does. Okay, here we go. I've got my numeric second, my categoricals first, starting with fewest to most. So you know what I think I want to do? Let's sort by numeric first, then unique, descending. Yeah, so I'm going to change this and say unique, and then I'm going to say ascending by think, I don't know why that's not working there. Let's see if that works. Yeah, okay, perfect. Up here, so now it's going to do my numbers first, since that's, so you know what I should do is let's sort by skewness after that, because that's our biggest problem afterwards. So let's do numeric, then skew, and then unique, and descending on all of them. I think that's going to be better. Perfect. So I got my numerics first, and now I can quickly see my biggest skewness issues. Miscellaneous value. Interesting. Yeah, that makes sense. Is there some sort of addition on the property that's miscellaneous that adds a value to it? If that's what that means, that would make sense that it'd be skewed. But I got a lot of them that have problems. But then here are a lot that don't. They're all underneath one. Very few that are left skewed, but they're all within a valid range. Anyway, let's move here. Now we're into the categorical ones, and we can see total number of values. 25. That's the only one that kind of worries me. We'll see if it matters or not. I'll leave it in for now. Okay, so what I want to do next is I want to look at histograms, but really only for the ones that worry me with these skewness scores that are way off. So I'm going to add a function that will go through and print out a, let's do a scatter plot. Well, no, I'm going to save it for the bivariate stage. Let's call this good for now, and I'll examine these histograms at the same time I look at the bivariate statistics so I can include them together in a joint plot. So we'll call it good for now on our univariate analysis.